Hello, and this is the solution video for the test review number 16 through 21. So for these directions, it says find the roots of the following equations, which means solve. So this time, not only are we going to factor, but we're actually going to set what we get equal to 0 and solve for the variable. So if we look at number 16 is super easy because we already have 0 on one side and the left side is already factored. So all we need to do is set x plus 6 equal to 0 and x minus 4 equal to 0. One-step equations, boom, done. Number 17, we're going to have to do a little more work. However, we do have 0 on the right side. So we need to factor the left. Because our leading coefficient's 1, we can go right into the double bubble. We don't have to use the box method. So we're going to ask ourselves what multiplies to positive 10 but adds to negative 7. Those two numbers are going to be negative 5 and negative 2. Now, in the beginning of this test review, you would have been done here, but because we're solving an equation, we have an equal sign. We need to set each of those parentheses equal to 0 and then solve. Add 5 to both sides, add 2 to both sides, 5 and 2. Number 18 takes it one step further. We don't have 0 on one side, so the first thing we need to do is add 6 to both sides. So we get r squared plus 5r plus 6 equals 0. Now it's just like number 17, where we can factor the left side using the double bubble method because we don't have a coefficient with the r squared that's not 1. So we ask ourselves what multiplies to 6 and adds to 5. It's going to be positive 3 and positive 2. Now that the left side's factored, set them both equal to 0 and solve. Subtract 3, subtract 2. Negative 3 and negative 2 are the solutions. Looking at number 19, we have two terms, but our first step for any factoring problem, we didn't have to do it for 17 or 18, is to take out the GCF. So for y squared and negative 5y, our GCF is y, and that leaves us y minus 5 in the parentheses. Now this is fully factored once we took out the GCF, so set each item equal to 0. And this time we only have to solve the second equation because the first one is already solved for us. Both solutions, y is equal to 0 and 5. Number 20. So number 20 has a leading coefficient other than 1, so we are going to have to use the box method. But first, I like to have the p squared term positive. It just makes it easier. So I'm going to divide everything by negative 1. I do not have to pull it to the outside like a GCF because it's an equation. As long as I do it to everything, it has the same equality. So I can divide everything by negative 1. And now because of that 6 in front of the p squared, I have to use the box method. First term in the top left, last term in the bottom right, which makes our magic number 30 when we multiply 6 times negative 5. So the two numbers that multiply to negative 30 but add to negative 1 are going to be negative 6 with positive 5, so go ahead and put those as the coefficients of the p term in the box. And remember, I could have put 5p in the top right and negative 6p in the bottom left. Let's factor out the GCF to the left, so bottom row and top row, and then left column and right column. So our factors, I'm just going to erase my little magic number to give myself more room, are p minus 1 and 6p plus 5. Set those both equal to 0 and solve. So my first equation gives me a solution of 1, and the second equation, I subtract 5 and divide by 6, I get negative 5/6. Number 21, we don't have 0 on one side. That's the first thing that needs to happen. I get x squared minus 100 equals 0. Now there's no GCF, but I notice x squared is a perfect square, 100 is a perfect square, and it's separated by a minus sign. So I can use my difference of squares. So the square root of x squared is x. The square root of 100 is 10, so that's my second term, and then always alternating signs for difference of squares. Now that the left side's factored, set them each equal to 0 and solve. So we get negative 10 and positive 10. So that will conclude the video for number 16 through 21. Check the playlist for more solutions.